Welcome to Homework Lib.
For the following table, we're asked to calculate the enthalpy of the following reaction, which is the one presented here. And everything is going to be in gas phase. So remember that the delta H for any reaction, we can estimate it as taking the sum of the energies of the bonds that are being broken, and we're going to subtract the sum of the bonds that are being formed. In this case, the bonds that are being broken are going to be, let's put it up over here, delta H of the reaction. We're going to have two carbon-hydrogen single bonds that are being broken. We're going to have a carbon triple bond carbon bond being broken, plus 5/2 of oxygen double bond oxygen. Remember that we need to multiply by the stoichiometric coefficient. Plus, in this case, in CO2, remember that CO2 has the following structure. So each of the molecule is going to have two carbon double bond oxygen. And in this case, we need to multiply by 2 from the stoichiometric coefficient. So these are the bonds that are being formed. So instead of plus, they need to be a minus. And we're going to have 4 carbon double bond oxygen. And finally, for water, we're going to form 2 single bonds of oxygen and nitrogen. Replacing the values from the table, carbon-hydrogen corresponds to 411 kilojoules per mole. Carbon triple bond carbon corresponds to 835 kilojoules per mole. Oxygen double bond oxygen is 494 kilojoules per mole. Carbon double bond oxygen is 799 kilojoules per mole. And finally, oxygen hydrogen is going to be 459 kilojoules per mole. After doing the operation, the result for the delta H of the reaction is going to be equal to minus 1222 kilojoules per mole. Just a note here, some professors like to put the value for delta H of the reaction as kilojoules directly, because in theory, when we are multiplying by the stoichiometric coefficients, we're multiplying by number of mole. But another very common notation is to have kilojoules per mole of reaction. So both of the approaches are going to be valid. Just keep in mind that you need to plug in the result with the notation that your professor is employing.